Hello ladies and gentlemen, we are getting ready to start 1.7 linear inequalities. Woo! We're not equals anymore, we're not equal. Therefore, we have to look at things a little differently. The first thing is how I'm going to have you answer your questions, as we're going to use graph inequalities and give a solution set. Using set builder, not so much. We're actually just going to focus on interval notation. I feel like it's the easiest to understand and the most widely used in the math areas that I have been involved in. We're also going to use properties of inequalities to solve inequalities, a lot like solving an equation. We're going to solve compound inequalities, and we're going to solve inequalities involving absolute value. I think we're going to do tonight to this point. This will be our video, and then we'll come back and finish the set of notes here later. I would like to point out that the handout I'm posting tonight is going to last today for this video and the next video as well. So keep that in mind. If this gets too long, I may break this video up into two pieces. So bear with me as we move through this. Okay. Ooh, that graph doesn't look very nice, does it? Graphing on number lines and interval notation. So we're used to seeing inequality statements. If we were to graph this inequality statement on a number line, it would look like this. We would have 2 and 3, and then on 2 and 3, we would put open circles, open and open, because they're not equal to, they're just strictly less than, and then we would shade in between, because all the numbers between 2 and 3 fit. If you pick 2.5, 2 is less than 2.5, which is also less than 3, so that certainly works. Well, in interval notation, an open circle is indicated by a parenthesis, depending on where your number is, what we're going to open or close the parenthesis. And a closed circle is represented by a bracket. One of these two brackets, depending again on the position of the number. So when I talk about open interval notation with this, I'm going to write it as parenthesis 2, because 2 is not included, comma 3, parenthesis because 3 is not included. When I write it like this means that all the numbers between 2 and 3, not including 2 and 3. Moving on to the next problem, I'm going to look at the number line again. Here's 2, here's 3. This time, however, these are equal to, so that means my circles are actually going to be closed, filled in, however you think about that, and then still shaded between. So it's going to look just like this, except for using parentheses with an open circle, I'm going to now use brackets because I have closed circles. And so now we are talking about the numbers between 2 and 3, including 2 and 3. So I'm going to this varies, the list goes on. This one's 2 and 3. This one's kind of wonky because the first one's an open circle and the second one's a closed circle, but we're still shaded between. So what we find out in these cases is that I can have a parenthesis around one and a bracket around the other, and that's completely okay. All the numbers between 2 and 3, not including 2, but including 3. And then it flip-flops on this one. I'm going to have a closed circle on 2 this time, and an open circle on 3, shade in between. Bracket 2, comma 3, parenthesis. Okay, so now let's talk about when I don't have two numbers involved. Oh, there's the bell for third hour. Nope, wait, fourth hour, I lied. Okay, I only really have one number that's going to have...
Coach Miller's weight class will be a little late to fourth hour. Andrew Castro, Aaron Penn, Will Shoemaker, and Carolina Smith, please come to the office.
Okay, so what we have now is we have this 2. It is an open circle because it's greater than. And if I think about all the x values that are bigger than 2, I'm actually going to go to the right because I have numbers like 3, 4, 5, and 167.222. Those are all bigger than 2, so I'm going to shade in that direction. The way we write that is we start at 2.
Again, Coach Miller's third hour will be late to fourth hour.
And then because it goes on forever...
Andrew Castro, Aaron Penn, Will Shoemaker, and Carolina Smith,
Because we go on forever to the right, I'm actually going toward positive infinity, that number that's out there it's very abstract, that number goes on forever, so we use infinity to represent that. And so if we look at this one, I've got 2 again, but this time I'm graphing less than, so we're an open circle shaded to the left.
Will Riley Page and Haley Starkey please come to my office?
Negative infinity to 2 this time because I'm going forever to the left. That means I'm going toward negative infinity and it stops at 2. I'm not including 2, so I do a parenthesis. This time, this is closed this time because I have this equal to, and I'm shaded to the right. And so what I have now is a bracket 2, but with infinity we still do a parenthesis. As a matter of fact, anytime we do infinity, we always do a parenthesis because infinity is not a defined specific place on the number line. It's kind of that abstract, out there forever. We're going to call it a parenthesis. So the same thing with this one. I've got 2. This is closed, but this time it's less than, so I'm going to go parenthesis negative infinity to 2 bracket. And then the last one is all real numbers. That means every single number on the number line. It doesn't matter what number it is, I'm still going to shade all of these numbers and go from negative infinity to infinity. And so that's kind of a rundown on how to use interval notation, and this is how we're going to give our answers. These are the answers I'm going to be looking, the form I'm going to be looking for your answers to be in the problems that are to follow. Wow, that looks lovely, doesn't it? Okay, hopefully it looks a little bit better on your handout. So we're going to ignore these dots. It says graph each. Oh, we're basically graphing. We're going from interval notation to what the graph looks like, just so you have another direction to look at it from. So here's negative 2 and 4. Negative 2 would be an open circle because it's got a parenthesis, and 4 is a closed circle because it's got a bracket. And when we have that statement, we assume that the numbers between negative 2 and 4 are shaded. On this one, we're at negative 2. That's a bracket, so we're going to do a closed circle. And this is going to our positive infinity, so it looks like that. And that's essentially x is greater than or equal to negative 2. Pretty simple. Okay, so now let's talk about solving inequalities. Okay, this is not a decimal point. Please ignore that. Let's just pretend like that's not there. We're going to solve each inequality, graph the solution, and the expression of the solution on a number line. So we're going to treat this just like it's an equation. We're going to get this x by itself on the left side of the inequality. So I'm going to subtract 3. Negative 2x is less than 8. Perfect. Now we divide by negative 2. Hopefully you remember from Algebra 1 when you did this the first time that when you multiply or divide by a negative number, that you should flip this inequality sign. So now what's less than, because I divided by a negative 2, you're going to have negative 4. Okay, so if you multiply or divide by a negative number, flip your inequality sign. Okay. So honestly, at this point, we spend a lot of time in lower years of mathematics drawing the number lines, putting negative 4 in, and then open circle, shaded to the right. Now, I am going to be really completely okay if you skip this step. I would only recommend you do it if it helps you see how to write it in interval notation. I will always model it, but I will not require it. Here, because we have an open circle on negative 4, I'm going to put a parenthesis, negative 4, and then I go to infinity because it goes on forever to the right. So this is your final answer right here. Okay. Next one. Ooh, there's that amazing magical decimal point that doesn't actually exist. Ignore it. Okay, so here I'm also going to get x by itself. So I'm going to subtract 5x. I'm going to add, nope, I lied. I'm going to subtract 6. Negative 8x is less than or equal to negative 8. If you divide by negative 8, you divide by negative 8, you get x is greater than or equal to 1. Okay, put that guy on a number line. 1 greater than or equal to means you're shaded to the right. Interval notation is bracket 1 to infinity. Okay, I am going to, in a moment, erase all of this and do this a different way because there's something I want to point out. Okay, so I got that big eraser. Oh, I made that decimal point come back. Let's get rid of them again. Okay, I typically do not like my x value to be negative if it doesn't have to be. And I know a lot of you probably practice this the same way. So there's something, if you decide to do the plus 3x and add the 2, I want to talk about. Okay, so these cancel and these cancel, and I have 8 is less than or equal to 8x. And then I divide by 8, and I don't have to flip my sign. But here lies a problem. When we graph these guys on a number line, you guys have kind of learned to graph the direction that that little pointy thing is going. So if you look at that and you shade this, you're going to shade this way, but that's incorrect. That rule only works if x is on the left and the number is on the right. So when we switch it, you still have to flip that sign so you can get that it's closed and shaded to the right. So always be very careful. When your x is on the right side, you need to get it over to the left and rewrite that inequality to get the correct answer. Okay, next slide. Ooh, that one looks scary. How did I teach you to solve equations with fractions? Was it something like maybe multiplying by the common denominators? I think that was what it was. So if you look at 6, 9, and 18, I'm going to multiply all of those by 18 over 1. So 6 goes into 18 3 times. That means I'm going to take 3 times x minus 4, still greater than or equal to. 9 goes into 18 2 times. That means I'm going to take 2 times x minus 2. Plus 18 goes into 18 one time, so I can just put 5. Super. Next step is to distribute. 3x minus 12 is greater than or equal to 2x minus 4 plus 5. 3x minus 12 is greater than or equal to 2x plus 1. Okay, gotta get those x's together. Whoopsie. And your non-x's together. So I get x is greater than or equal to, those canceled, 13. Oh, that's it. I'm going to go to 13. I'm going to go greater than or equal to it. Man, all the answers seem to be going the same direction, don't they? Okay, so bracket 13 to infinity. Compound inequalities, this is super fun. This means we have and or ors. Oftentimes the and is written, so like consider this, that negative 3 is less than 2x plus 1 and 2x plus 1 is less than 3. Because these share a common statement, we can put them together and make them a compound inequality like this. When this is the case, when we graph those, we have to, when we solve those, we actually are solving 2 equations simultaneously, so we're like going to subtract 1 in 3 different spots. So we'd subtract 1 here, subtract 1 here, subtract 1 here. And so I'm going to rewrite it down here. Subtract 1, subtract 1, subtract 1. So the first equation ends up being negative 4 is less than 2x. Second equation ends up being 2x is less than 2, but we're doing them together. It is a compound inequality, just like you have a compound sentence. 2 sentences in one, 2 inequalities in one. After I divide by 2, I get negative 2 is less than x is less than 1. Ooh, this is one of those. Here's negative 2, here's 1. They're both open circle, and we can shade in between. So in interval notation, negative 2, comma 1 with parentheses around both of them. This is the answer I'm looking for. So let's do this one, and we'll be done with this part of the notes, and we'll talk about the rest of them tomorrow. So I'm going to subtract 3 in all 3 spots. And so we get negative 2 is less than or equal to 2x is less than 8. Then I'm going to divide by 2. Negative 1 is less than or equal to x is less than 4. This one's kind of funky because it has an equal to on this one, and oh wait, we've seen something like that before for graphing. One's an open circle, one's a closed circle, one's a bracket, one's a parenthesis. It's pretty straightforward. Negative 1, 4, closed circle, open circle, bracket, negative 1 comma 4 parenthesis. Fabulous. So I hope you enjoyed this video. Remember, the handout that I'm going to upload with this video is going to have stuff for tomorrow night on it, so you can actually use it for 2 videos on 2 nights in a row. The bad joke of the day, I almost forgot. How can you make 7 even? Take off the S. This is Mrs. Lauer signing off. You guys have a great day.